In the last 100,000 years, the nation of Indonesia has consistently been one of the most frequent sites of large magnitude explosive eruptions. These range from the Toba supereruption 74,000 years ago, to two caldera-forming eruptions of Krakatau, to the 1815 eruption of Mount Tambora, which caused the so-called year without a summer. While these three volcanoes are well known, there are also a number of lesser-known similarly explosive counterparts. Several of these volcanoes can be spotted by the massive depressions relevant eruptions formed in the ground known as calderas. One such lesser-known caldera is the Ranau of Caldera, which once produced an eruption at Ranau of Caldera at least 3 times larger than Krakatau's famous eruption in 1883. This ancient eruption created the modern Lake Ranau, which loosely outlines the caldera formed by its catastrophic eruption. Although this specific volcano does not have a single known eruption in recorded times, it may still have produced volcanic activity. At least twice in the last century, a strong sulfur odor was detected originating from the lake, and this coincided with a mass die-off fish within the lake. This does not mean an eruption occurred, but rather that fumaroles showed an increase in activity within the lake, suggesting that there is still an at-depth magma chamber. The Ranau of Caldera is located in southern Sumatra, where it is 350 kilometers northwest of the geologic setting city of Jakarta. From satellite, Ranau's most prominent feature is its large caldera, measuring 16.5 kilometers long and 12 kilometers wide. This caldera is quite interesting, as it is located along a lengthy strike-slip fault line known as the Great Sumatran Fault. Pull-apart basin, the area where the volcano is and its caldera are bounded by 2 parallel strike-slip faults, although one of these is no longer active. This caldera represents what is known as a step-over or pull-apart basin. A step-over forms when strain at the end of one strike-slip fault transfers to a parallel fault, causing the area to spread apart over time. Thus, any volcanism along this fault can be assumed to occur as the area represents a path of least resistance, allowing for any molten rock intruding into the crust to erupt into this weak point. The exact geologic history of this complex remains unclear, but here is what likely occurred. Stepovers typically are low points in the terrain, meaning that before this volcano produced its catastrophic eruption, it likely did not have much of a prominence. Instead, it likely consisted of a group of distant lava domes, most likely of an andesite to dacite composition. Remnants of 2 such lava domes and viscous flows can be found on the western side of the caldera. These formed through highly explosive eruptions which generated frequent pyroclastic flows. At some point, a massive highly silica-rich magma chamber began building underneath Ranau, involving a volume of more than 100 cubic kilometers of material. Eventually, this material became primed for a major eruption. Although we cannot be sure of this, the eventual eruption was likely caused by a large magnitude earthquake on the Great Sumatran Fault. I am basing this assertion on the fact that the now more highly active Suo volcano seems to produce highly explosive eruptions in the weeks following a large magnitude earthquake, such as in 1933. Regardless of how the eruption was triggered, a massive eruption began at Ranau 33,640 years caldera-forming eruption ago. As a plume of ash shot more than 45 kilometers into the atmosphere, part of the voluminous eruption column collapsed downwards, producing long-reaching pyroclastic flows. These pyroclastic flows were largely controlled by topography, scorching the landscape and wiping out all life up to 85 kilometers distant. For example, the city of Megaeruption, which is 40 kilometers distant, was buried by 4 to 5 meters of ash. Then, due to the large amount of erupted material, the underlying magma chamber had been severely drained. This caused a large section of overlying rock to collapse downwards to fill its empty space, forming Ranau's modern caldera. In total, at least 150 cubic kilometers of volcanic rock was ejected, meaning the eruption had a volcanic explosivity index of a 7. In the aftermath of this eruption, the semeru stratovolcano formed in the eastern section post-caldera eruptions of the caldera, with its most recent activity likely occurring only 5,000–10,000 years ago. Thanks for watching. If you would like to request a specific topic, please leave a comment below. Additionally, I would like to thank MacBeach for supporting this channel.